Hello guys, welcome to another question, and we're discussing the minimum platform question number 12 from much to coding questions of Geek for Geeks RX. So just have a quick look at the question and we'll be discussing it soon. So before that, just please don't forget to subscribe and like. So if you have any doubts, just comment down in the below. Okay, now going to the approach. So in the question, we have given array. This is not array, this is arrival time, and this is a departure time. Now we have to find out like how many trains could be there in platforms, like at the same time how many trains could take platforms. Like if one train is coming and another train departure time is less than the arrival time of other time, then in that case one platform will be empty. So where the platform is empty, the other train can come. But the if other train is occupied and its departure time is late than the other train, then it has to take the new platform because there is already one train sitting at one platform. In this case, we add if the departing train is earlier than arrival train, then we can just replace the train at where the train is departing. We can just get to that same platform. Okay, so now in this process, what we have to do is we have to sort both arrival time and departure time. Okay, in case of arrival time, this is the same case. It is already sorted from small to big. Okay, now just I will be writing down below. Now we could exactly see which train is coming first and which train is departing first. Okay, now we have to use two pointers here and initialize. Okay, I will be starting from one here because one train will always be there at one platform, right? Whatever the first train will be there, it will always be at that platform. So we won't be starting the arrival time from I equal to 0. Okay, we will start from I equal to 1 for that reason, and we'll take another pointer that will be j equal to 0 here. Okay, that is the index value 0. Now what is happening, as I told, we have to compare the arrival time and departure time. If the arrival time, okay, if arrival time is greater than the departure time, means departure time is smaller than arrival time. Okay, if it happens, we update j, because if departure is smaller, then one train is being left out of that platform. So j will be updated to j plus 1. It will move one index forward in this case. And we will also, we will also initialize number of platforms that we need. How many platforms we need, that will also be initialized 1 at the start. And we also take a maxi value as 1. Maxi and need will be same. Okay, I will be explaining why we are needing these values one by one. So this is the case, first case, if arrival time is greater than departure time, then we update the j value. And as I told, one train will be leaving at this point. Okay, so if this is the needed, so how many platforms we need currently? So before it was one platform for the first train we need. Okay, now but the train has left, now we don't have any need of that platform. Okay, so we will update this need as need equals to need minus 1, because one train has left, now platform is empty. As we do this, we also take the maxi and take maximum of need and maxi. Okay, we use maxi and we take maximum platforms required, because we have to find maximum platform required at the final output. When we iterate to the whole loop, then we have to get the maximum platform required for all the trains. Okay, needed was at first it was 1, but it is 0 now. So another train can come now. Okay, but it was 1 before. Okay, we take need and maxi, we take maximum of this both. Whatever the greater value will be, that will be replaced by maxi here. Okay, now let's just carry this to the example. Okay, now if arrival time is greater than departure, we do this. Else, if departure time is greater than the arrival time, then the train is not going anywhere. Okay, the old train is just staying there and the new train is coming. If the new train is coming, then we obviously need a new platform. So need will be updated first here. Need will be need plus 1 here, because we need a new platform. The old train is staying in that position only. So need plus 1. Now again we'll take a maxi here, same. We use the maxi here also. Or you can use a maxi out of both of if else's. Okay, that will also work. And there is also one part here, we are updating j, right? J plus 1. So in this loop, we will update I equal to I plus 1. Now let's discuss through this example what is happening in the loop. Okay, from the start, okay, here we're comparing 0910 and 0940. Before this needed platform is 1, right? Before this need is 1 at this time. Now after comparing, the need will become what? 0, because departing train is smaller than 940, and we are doing subtraction here, 9 minus 1 in the condition. So this will become 1 minus 1, that will be 0. At this position, that will be 0. And you also have to take care of the maxi. So maximum starting is 1. Okay. Maximum starting is 1. It will again be 1. Okay. With 1 maxi and the current value 0, maximum of these two is 1 only. So it will be 1. It stays 1. Okay. Now j will be updated after this. J will be equal to 1. J will be here. That will be equal to 1. Now we compare arrival time and departure time. So departure time train is greater than the arrival time train. So in this case, we update I plus 1. So I will come here at this position, I will come here. And what happens when it comes? Need will be added. So new train has to come, but already the old one is occupied. So that's why you need one platform more now. So need is updated, need plus 1, and I is also updated here. So I is now here. So out of maximum previous value 1 and the current value 1, maximum will be 1 again. Okay, now Y is here. Now 950 and 1120. Again, we need another platform because the old departure time has not departed yet. So again, the need will be updated. This will become 2. Now out of 2 and previous value 1, 2 is the maximum value. So maxi will be updated as 2 now. Okay. And I has updated. Now it will go to this position. Now it checks with the previous value. Is departure time smaller or greater here? So departure time is greater again. So this time it will become 3 and I will also be updated here. Now I will be here. This has become 3. Out of 3 and 2, what is the maximum value? That is 3 here. Okay. Now we are at 1500 position. Now we compare again. Now departure time train is smaller. So need will become 2. We are minusing 1. Okay. Now J will come here at this time. And out of 2 and 3, what is the maximum value? That will be 3 again. So again, 1130 is smaller than 50. Again, minus 1, this will become 1. And maximum value again will be 3. So I will be updated to here. So 15 and 1200, again, departure time train is smaller. So this will become 0. But maximum value will remain 3. Right? It will remain 3. So departure value will be updated here again. Now here departure time train is greater than arrival 1. So we need will increase by 1. But maximum value will stay 3 here again. So I will be updated now here. Again, departure time train is more than this. So what happens if the departure time is more? Then we update the I value. But there is no next value. So this will be the end of the loop. And need will be updated to 2. Out of 2 and 3, maximum is 3 again here. So this is how it works. At last, we get 3 value as the maximum required platforms. So this will be the output for this question. Now let's just have a quick look at the coding output also. Then you will be understanding it very clearly. I hope we have got the part that I want to explain. I hope you have understood. If you have understood, just comment down below. So this is the coding part of minimum platform. First we have sorted arrival train. Then we sorted departing train. Maximum platforms required is 1 at the initial stage. And then the need is 1 at the initial stage and I equal to 1. Okay, I will start from the first index. Then we are taking a while condition where it states I and j both should be smaller than n. If any one case has exceeded, then we don't have to check other array. So these are the two conditions that we talk. If it is greater, we update the need as -1. If it is smaller, then we update the need as +1. As we have discussed earlier, this is the same approach that we have implemented in the coding, and we'll taking the maximum of need and maximum platform required. At last, we'll be returning the maximum value, max p, which is the minimum platform required for the trains. I hope you have understood the question. If you have understood, please say yes in the comment box, and also don't forget to like and subscribe. And thanks for watching till the end. We'll be meeting in the next question.